Give me thumbs up. Anyone? Yes. Okay. Thanks. I never know. Okay. Uh, Today we're going to talk about fire and smoke resistant assemblies. Last week we dove into active type of assemblies like smoke detector and heat detectors, fire extinguishers, things like sprinklers, things that we physically use to manually put out fires. Here we're going to talk more about what's inside the walls. This is more of a passive fire protection in lieu of active fire protection that we learned last week. So let's get started. What we want to kind of focus on is introducing the concept of passive and active protection systems, like what's the difference, explain various types of rating assemblies. And what I mean by an assembly, we're usually talking about a construction assembly of a component like a wall. Or so when they use the word assembly, it's an assemblance of some construction detail, okay? Mainly walls in this case. Discuss the differences between fire and smoke barriers. There's a little different. Last week we talked about a fire detector and a smoke detector. There's a little difference between in this passivity, how in the walls they protect both from fire and smoke differently in partitions, and then explain the separation of various parts of the means of egress as required by code. So we want to get started. Okay, so a little bit of what we were talking about last week, a little review. We just keep building on, and you guys can really see everything starts from occupancy load. We then, from there we place our exits. From there we know the widths of our exits. From there now we're going to learn how to place our fire equipment, and then we're going to get deeper into these systems, into the actual walls themselves too. So, exiting systems, elements of a space or building that assist occupants to safety, exit access, exit passageway, exit corridors, the exit itself or exit stairwell, and even a horizontal exit. Okay, remember that's like a whole room that you hold in case you're a prison or an institution. Also, you can have an exit ramp, areas of refuge, exit discharge, where you leave that exit into out of the building, public way. We also talked about travel distance. That is the complete distance from once you also calculate the common path of travel, which is the distance within the office that you are in. You add that distance, and then that distance from the moment they get out of their office to do two different exits to the exit. So it's the total distance a person has to travel when they're just sitting in their office to get to an exit. And the exit element sizes. Remember that based on occupancy load, we have these factors that we times something by. If a sprinkler or a building is not sprinkled, you would, in order to find out how wide your stairwells have to be, you would take the occupancy load and times it times 0.3. And then you would divide that number by how many stairs there are, and that tells you how wide they have to be. But if the building is sprinkled, you can actually have a narrower stairwell and times it by 0.2. However, there's a minimum. Does anyone remember the minimum of a stairwell? What the minimum width has to be, regardless of your math? There's a minimum that they require. So a lot of times,
44 inches.
yeah, 44 inches. Thank you, Trina. Yeah, so 44 inches. So, a lot of times when you're dividing and you're timesing it by 0.2, it's less than the minimum, so you have to go by that. And then how we find our corridor widths and our actual door widths, we also times that by 0.2. So that's a lot of all the exiting systems we've been doing and worksheets. Last week, we kind of touched base on active systems, okay? Must be activated in order to work against the fire. So something has to be activated. You have to pull the trigger, squeeze on the element. Okay. So fire alarms we talked about, how they can be smoke and heat or a combo. We talked about fire extinguishers. Do you guys, anyone remember how far a fire extinguisher has to be from each other? That's code. There's a maximum distance a fire extinguisher has to be from one another. Anyone remember that by any chance?
Is it 30 feet?
Oh, 30 feet? A
Is
little,
it 30 or
what?
70? Is it 30 or 70? I can't remember.
75. It's
Oh,
75.
75.
75 feet. But you have to have, but so if you put it 75 feet, but if the space, so you need at least one fire or fire extinguisher per 3,000 square feet. But if that 3,000 square feet is laid out so weird that it's more than 75 feet to an extinguisher, you may need two. Okay, but usually the code is at least one per 3,000 square feet, and they can be no more than 70 or 75 feet apart. Okay, good, good. We talked about emergency lighting and the flashlight, and the best placement of it is to show where an exit is or an exit corridor so people can get to an exit. And we talked about the audio visual, the like strobe light or the thing that flickers. And a lot of times those two are paired together so that someone can see if they're deaf, and then the light will always guide them to the space. Standing pipes, those are actually built into structure where you can actually put a hose on there and are able to actually manually get water from that system. And then the automatic sprinklers, you guys laid out the sprinkler trunks. Remember, you come in 7 feet 6 inches, and then every 12 to 15 feet, you just lay another trunk. Okay.
I have a
Very,
question on that
yes.
real quick. So when you're doing that and you end up like at the end of your run,
Mhm.
so like is if you had less than the six
Yeah.
to seven
Yeah.
feet, what would that?
Just that's fine because this is, if you zoomed out, this would be in an entire commercial space. So those trunks would continue throughout the whole building. Do you know
But
what I mean?
so it doesn't, it really doesn't matter. Like if it's hypothetically, if the building did stop there
Yeah.
and you were kind of, would you
Then,
still, would it
yeah.
be okay?
As a mechanical engineer, I would center it in that if it's like 2 feet from the wall, I would pull it and center it in the middle of that room.
Okay.
Yeah, you know what I mean? Or, keep it so that it makes sense. So it can spray because it sprays, it sprays about 7.5 feet. So you
Yeah.
would probably adjust it. And they
Okay.
do that all the time. This is just code to lay them out so you get the minimum. Yeah, but that makes sense, right? You coordinate it with what's going on with the walls and the space. So good question. Thank you. We also talked about that life safety plan and the emergency communication. And nowadays, our communication is mainly this, the phone. But there are emergency communications. There's always usually one near an area of refuge that tells people, you press it, and so it tells you that you're there waiting. Please come rescue me. Else they wouldn't know. Ones that might be verbal or announcements or, computer generated. So those are active. And then today we're going to go into the passive systems, the ones that are integrated into the building. Okay, so kind of they focus on prohibiting and containing a fire. So we're going to talk about separations of one area of a building from another by the use of fire rated assemblies, walls, floors, and ceilings. So when we deal with this fire rated, and use the word assemblies, they're usually dealing with floors, ceilings, and walls. Those are assemblies. Creating smoke barriers, how to do that in partitions to prevent the flame from spreading or the smoke from spreading from one space to the other too. And using radiant doors, windows, glazing, and frame assemblies. We're going to talk about, not only are you doing the actual wall, but anything that's in that wall has to be rated as well. It has to be fire, have fire resistant elements. So we talk about that. Okay, lots to go. Okay, so that's where we're at in this whole really weighty chapter about fire passive systems. So this gets a little like technical, but we'll put it into a practical sense when we start doing the worksheets. Okay, so passive systems. So they focus on prohibiting and containing that fire, smoke and fire barriers, and petitions like in the walls. We often call a wall a partition, just so you know. If I say, okay, well, because we're going to do a partition schedule, that actually means a wall schedule. Okay, just in the layman's terms. Okay. We're going to talk about horizontal assemblies. So you have vertical assemblies, which are partitions or walls. Then you have horizontal assemblies that are roofs and floors. So you're in a little box right there. Okay. We're going to get into the operating protective elements like a window or a door and things that are also integrated in those partitions. Through penetration protection protectives, we're going to talk about when you have to have a penetration into a wall to another space, like HVAC and stuff. What are things that we use to stop smoke and heat transfer? These are dampers, fire stop. All this is in the NCIDQ too, by the way. I thought I was like not going to need to know this, and you do. And IDEX. So have an understanding that when you penetrate through a wall, there needs to be protection. And this is why you and I, as designers, have to be careful when we start breaking down walls and stuff. Because if it's in a protected assembly, you've just now made it unprotected. Okay. So through protective, okay, so we're talking about this, finishes. So this goes back to finishes. This really pertains to us. Finishes, furniture, wall coverings, floor materials, upholstery pieces, drapery, things like this, mattresses, similar elements. These things also, you know, when we do different, you know, are part of the system, and also protect fire protective assemblies found by the National Fire Protection Agency. Some codes and standards from the life safety. We're going to kind of go over those as well. So it's good, sir. So here you see fire as a little bit of a situation here. They're saying this exposed side. Okay, and they're just showing the fire is here. And so what makes this side, this is not unexposed. How do we keep an assembly like a big wall? How do you keep it from spreading? So I'm going to get into that. So some of these passive components um, and are created by fire resistant rated assemblies, which include firewalls. We're going to talk about fire barriers. Okay, so you have a full firewall or a fire barrier. Okay, they're similar but not the exact same. And this is also something you'll have to distinguish, you know, when you study more about the test. Something that's more a firewall is more protected than a fire barrier. Horizontal assemblies, like I said, floors, fire partitions. Okay, so these components limit the access to other parts of the building to create a barrier. Okay, so you don't want, you want some fire resistance here so your fire doesn't spread to the next floor. Okay, so this is where we would create some of these assemblies. Okay, so let's say this is a 2-hour fire rated assembly. What is typically in that? And this is literally what they do in the test, you guys. They actually drag and drop and make you actually take it. You have like a little detail and you have to drag and drop all these components. It's like, oh my gosh. So a lot of times here, you know, you may have 2 layers of a gypboard. Gypboard is already intrinsically fire resistant. So when we try to do a 2-hour fire rating, you usually requires 2 layers of 5/8 gypboard. That's one of the elements. Um, like this is a suspended ceiling for just by the way. So this is a suspended ceiling. So they're using their gypboard. They've got their drywall suspend or these are, I'm so sorry, it's not suspended. It's just a hard lid ceiling. So they've got drywall, then they've got their little drywall systems. Then you have this little right here, this little cold form steel flooring joist. So if this is a flooring assembly, so this flooring assembly is got extra protection. Here they have fiberglass insulation that helps also. And then you may see dragon board on top, which is another structural panel. So this would be a fire assembly, 2-hour fire assembly for a floor. When you get into like walls, okay, they're different types. This gets technical, but let's say you're over, this is just, you cut the building, okay? This side has a little ceiling assembly right here, okay? Fire resistant rated floor ceiling assembly. So here they've got some assembly here. Over here, it's non-resistant rated floor ceiling assembly. So they don't have that extra protected barrier. Okay, so this is a little different. Here on the actual floors themselves, they have a fire rated assembly. So somehow in it's concrete maybe, and they're adding in the elements that make it fire resistant. But if this one's got the assembly and this one doesn't, you want to make sure that your walls have some kind of protection. Okay. Here, this is the upper floor, or we call the roof deck right here. So here they made this area, they just added and continued a fire rated ceiling assembly, and then therefore making this roof more fireproof. So these are some of the things that they do. They're adding all these components. Okay, I don't want to get too much into it, but this limits the access for fire to get all the way up to this second floor. Okay, it's by adding all of these protected elements. So let's say you had this awesome ceiling and you wanted to like cut into it to create like a recessed tray or something. This is where you need to know that that's a fire rated assembly ceiling roof situation, and you can't do that. Or or you decide that you want to push in some different kind of lighting, and therefore you're creating a penetration, and you need to make sure that you are caulking it with a fire resistant sealant, so you are not spreading the fire. So this is why it kind of matters. Because you deal with ceilings, you hang things up, you design RCPs, and so you want to know what's going on in the ceiling as well. You don't want to compromise it. Okay. Let's talk about, this is interesting. This is a parapet. This is kind of a funny little thing. So passive firewalls, okay? Passive firewalls provide complete vertical separation between an area in a building and must extend continuously from the foundation all the way through the roof. So it is a complete vertical wall that goes from the floor all the way what we call the deck, or the top, the very top. So it would go right to the very edge of the end of the roof. Okay. It's not so when in that way there's no gap. Sometimes a partition will go just to a little past the suspended ceiling. It's cheaper to do it that way, and therefore there's a big air gap that smoke can go through. So if you add a firewall, you have to make sure that it hits all the way to the top of the roof, or what we call the top of the deck. Okay. So from bottom to the top of the deck. Okay. Um, a parapet wall, this is funny. They go a little further. So they extend it and push it up just to even create a visual separation between two different buildings. Okay. So when the firewall extends past the exterior walls and roof for extended fire protection, why would you need something like this? Maybe if you had a townhome with two different homes,
I was
right?
gonna say,
They're
is that a
connected.
duplex? It looks like a
Yeah.
duplex.
Yeah, that is a duplex. And you really want to make sure it's not just like you're in an office and they're doing this, is like your two homes connected. And so that makes more sense to really make that separation. Now, a party wall, when a rated wall is located on a lot line and shared between two structures, that's what we just use that term. So if it is a wall, it's like an extended building, but it's its own building, but it has a shared wall. Okay, sometimes buildings will do that. We call that a party wall. Okay, those usually have to be rated as well. Okay, built so that if the construction on one side of the wall fell during an emergency, the firewall and construction on the other side would remain. These party walls are extra strong. So let's say that crumbles. It's like a wall connected to a wall. So that portion falls, but you're still standing. Okay. Minimum 2 hour fire rating, rated based on occupancy classifications and loads. So firewalls are 2 hours. Just so you know, they're 2 hours. They're from floor all the way to the ceiling. If you push it up, it's a parapet wall. A party wall is when they share that wall together, and it is structured in a way that if one building burns down, the other portion of that wall stays put. And it has to be 2 hours. So when you see this, okay, the party wall is double here. It's an extra, and so that would fall away. So anyway, one takeaway, firewalls have to go from the floor to the deck or the top of the roof and must be 2 hour fire rating. Okay. Now, fire barriers, okay, horizontal assemblies, floors, ceilings, and fire partitions, we're going to kind of touch those because they're a little different. You kind of got to know. We'll watch a little video. Okay. He explains it better than I do. Fire barriers, okay. These are walls that have a fire resistant rating with limited number of openings. So if you have a fire barrier wall, you need to know because if you want to cut into that wall, you're only allowed a certain amount of square inches, okay, or a window. There's a rules, okay? Fire barriers are used to indicate vertical rated walls that separate a certain area, or they're used within a building and must extend from the floor all the way to the ceiling or what we call the bottom of the deck. So if you were in a high rise and you were just on the first floor, it would go from this whatever the floor is all the way past the T molding all the way. And when you hit the actual concrete of the floor above, that's called the deck. And in between space is the plinthum. And that's where we run all our HVAC and we do T-bar systems and stuff. So that's, so still fire barriers still have that restriction. Now, fire partitions, they're similar. These two are confusing because they're similar, you guys. They're almost the same thing, but they're a little different. Okay, so similar to fire barriers, and are often used to separate, let's say, a corridor from an office, okay? A tenant space, like if you're in, space A and someone's in space B, they'll use like fire partitions, okay? Dwelling units, sleeping units, and areas of refuge. So rated for at least 1 hour. So those are kind of dumbed down to 1 hour. Um, Less stringent than the barriers. The barriers are more strict, probably at 2 hours, but they can even be 3 hours. It just depends. Does not have to be supported by a horizontal assembly. So this, it can be just vertical, just the wall, and it doesn't necessarily mean that the ceiling or the floor has to be fire rated, but it's just dealing with a partition and so that it keeps it from penetrating to the next person. Okay. So let's take a little, horizontal. So those are those ceilings and floors. Okay. The partitions, the fire barriers, we're talking more vertical. Are floor and ceilings, roof assemblies that have a fire resistant rating. So any horizontal assembly, if it has a rating, must extend horizontally from one rated wall or extend wall to another. So if you're going to have a horizontal assembly, it has to go from one rated wall to the next rated wall and seal off there. Okay. You can't just go from one rated wall to not a rated wall. It has to be sealed off. So let's just take a look at this. He kind of explains this good, but basically fire barriers, a little more stricter, fire partitions, they are rated and they're usually about an hour rating and they're used to separate tenants from each other. And horizontal assemblies are also rated, but don't necessarily have to have a vertical partition. So let's just take a look really quick. Okay.
Hello and welcome to Archie Corner. This
Can
is
you guys see
episode
this?
number 15.
Yes.
And today we're going to answer the question, what is a fire-rated wall? Actually, no, we're not. You won't find the term fire-rated wall in the building code. Instead, you will find the term fire-resistive rating. And depending on the application, you will either have this fire-resistive rating provided by a firewall, a fire barrier, or a fire partition. Although they are quite similar, they have different applications, and therefore they're a little different the one from the other. Here's a quick list
Can you
showing
guys see
when
this?
each one of these items are applied.
Yep, okay.
And you can see by the fact that a fire barrier has a longer list that this fire barrier is one of the more common applications. Not that the other two are less important, just that this one is the more common one. Regardless of which one of these we choose, each one comes in different fire resistive ratings. More specifically, in time ratings of 1 hour, 2 hours, 3 hour, and 4 hours. By now you've probably already figured it out. This is not rocket science. What this means is that if there was a fire or similar danger in a building, a barrier would need to be placed at strategic places as designated by the building code so that the occupants can remain reasonably safe as they exit or get help exiting the building. In lower risk applications, a 1 hour rating would be sufficient, whereas in higher risk applications, you would need a higher rating. Although this is just one of many applications, a sample would be stairs. You need to access stairs to exit a building. If the building is 3 stories tall, a 1 hour rating may be sufficient. But if you have a skyscraper and you have like 100 stories, well, a 1 hour rating may not be enough. And you see, that's it. Nothing to it. Now you know the basics of what a fire resistive rating is. And next time someone asks you they need a fire rated wall, you can probably sound a little smart and say, do you really mean a fire rated wall? Because I think you might need a fire barrier, not a firewall. Perhaps even a partition.
Ah, sorry.
And just look at their startled faces
Oops, sorry.
while you laugh inside knowing that you outsmarted them for a minute.
Yeah,
Thank you again very much for watching this
That
video.
was short.
I hope you find it useful. If you liked it, don't forget to hit that like button. If you like these types of videos, don't forget to subscribe. Below are a few other videos that I think you might like. But for now, this is
Okay. So like I said, fire barriers and firewalls, they're about the same thing. So there's really no such thing as firewall. Okay. So in here they kind of go through the different kinds of sheetrock and things that you need and it's extra protection and everything is sealed. So now we're going to talk a little bit about passive horizontal assemblies, acceptable versus non-acceptable. So horizontal assemblies, once again, are ceilings, roof ceilings, and floorings. Okay. So this is what can happen when you're looking at this, y'all. A path for the fire to spread. So when you have an opening, okay, so this is the wall. And what I said before is that that wall cannot just stop at like a ceiling assembly, like a T-bar. Else the fire will jump past that into this area, which we call the plenum. It's a space, like the crawl space where all your HVAC is. And it will jump and it can get into the other space. So this is not acceptable fire assembly. Like I was explaining, you need to push that vertical wall all the way to the top of the deck or it's underneath the actual flooring of the next floor. It has to be pushed there so it seals this fire path spread and it cannot penetrate through there. This is why this entire assembly is got it. You can't have penetrations in here, else it could squeeze through here. And this entire element has to be caulked and sealed. Okay, so it just closes it off. It's like leaving a gap. And what are you gonna, with the gap? Sorry, my mouse just slipped. Go. So, oops. Oh, what happened to my? Oh, sorry, guys. Let's see somehow. There it is. Okay, where am I? No. That is so bizarre. Sorry about that. I'm purchasing. I don't know what happened to my. It's trying to find my canvas. It's so bizarre. It just kicked out. Sorry, right in the middle of them. Oh. So bizarre. Let me stop the share really quick. It kicked me out of Canvas. Don't ask me why. That is so weird. Let me re-log in and get back to the. That's so bizarre. Tell you. Okay. Thanks for your guys' patience. People will kick back at that. Back. Okay, we're back in business. Don't ask me why that didn't want to cooperate. Oh, so annoying. My computer just now. Okay, there we go. Let's just get into back where we were. Love it, technology. Okay, 14 days of time. Okay. Well, the good news is I have this on my computer. I could always just turn it without Zoom. Okay, let me share back the screen. Let's get back where we were. Okay. Okay, so we are talking about this little penetrations, and you see right here, they're kind of talking about that ability. Okay, so here when we can find these in, where do you find all these little hour ratings? Right here. And I don't know if you guys can see this very well. Let me make this a little bit bigger for you. In the NCIDQ, we can find what assembly has to be what hour protected rating. This is where we're going to find out what on our worksheet, what needs to be 1 hour, 2 hour, and so forth. So, and they break things down by hazard, by assembly groups. Okay. So when we go to table chapter 7, and we start, it's in 5 and 7, there are different informations. One talks about the height of the building. Just like that video said, the higher the building, the more hours of fire assembly. He said for a 3-story building, you might need 1 hour or 2. But if you had a 14-story building or 50, you might need a 3 hour. Okay. This is where we find all this information. And so here it's talking about assembly A, B, E, H for 1R. Factory, mercantile, and it will get into different hours of ratings on different parts of the elements. And so all of this can be found for fire barriers, fire walls, horizontal assemblies between areas. So if you were looking for that, and one of the things you might know is, let's say you don't know that information, you want to do something to the ceiling, and you found out, well, I could find out how they build this if I look up how high this building is. I know the construction type, and you might be say, oh, based on what I know, they would have had to make this a fire barrier wall. Like you can actually do deductive reasoning, figure it out. Here's also table 508.4, separations between and occupancies between occupants. So if I was in, and I know this is not, let's see if I can make this bigger. Oh, there we go. Make it bigger for you guys. So if I was in, let's say, a business occupancy, see that right there, B? Okay. I'm in a business occupancy and I'm next door to an assembly. Okay. Let's say it's I don't know, that training room. I'm in a business, I'm next door, and I'm in a sprinkled building. I only need it to be 1 hour fire rating. Do you guys see that right there is a 1 hour. Now, if the sprint build is non-sprinkled, I need it to be in a 2 hour fire rating. Okay. And then they get it all the way into all these different. Now, if I am a business and I'm next to a business, I don't need to be rated at all. Like it's not even a thing. Okay. Because assembly has more people. It could be a bar or something like, a restaurant. So it's going to be more higher. So let's take a look at if I were an assembly and I was next to a mercantile. I would go here and I'm going to look and find an M up here. Let's see, is mercantile right there. I'm in a sprinkled building. I am in next to mercantile. I need to have a 1 hour fire rating. You guys see that? This is how we kind of find out. This is this 508. This is how we find out when you're looking at this, what needs to be what. Okay. We look at this chart. So that tells you all the different. Now, if I was an assembly and I'm next to an assembly, okay, it's actually saying for some reason, this assembly, and it's right next to assembly, does not have to be rated if it's sprinkler. So I don't know, go figure. So it's really interesting. So you look at what your occupancy is and where you are, and it'll give you the number. And right here is just kind of where we found that chart. I always like to show you where it really is and the building codes. And this is table 508. So when it's going to bounce to that. I don't know. Maybe it won't do it if it's. So 508, if we go to 508, you guys, because you'll probably need to know where this is. And this is a lot, gives you the heights, some great charts on all the different kinds of assemblies, different kind of construction notes. Where, where we're saying sprinkle, non-sprinkle, we all looked these up before, remember when we saw, how high can this be? So that's all found in this chapter. How many stories can this be? So now it's also telling you what's the fire rating between it. So in here's a good one too, based on the type of construction, allowable area, how many square foot it can be. So we looked up all these charts, but when you go to 504, I think it was 504, did I already pass, or 508, 508, be 508. Oh, here's also other good stuff. Is it 508, 504? 508.4. Oh, separation occupancy right here. So here's where it gives you the full-on chart, and it looks like a lot of it is blue. I wonder if there's changes. So, because remember we talked about blue. It looks like only assembly and E didn't change, but a lot of this other did. So this is very fascinating. It looks like maybe because of the new sprinkler law, they're making it less. So, very interesting. Okay, so a lot of this has changed. So it's good to look. It's good to look. So let's just see if we still if we're in a business and we go to occupancy, we're still at 1 hour. So that's good to know. Okay. And anyway, that's where we're finding that right there. Very handy. Also smoke protection features. Now, passive fire protection. We're going to talk about these little different areas, okay? Here you've got simple units and they're separated by walls, like you would have, let's say, a condo community, okay? So fire areas. When fire barriers, vertical and horizontal, so fire barriers and exterior walls are used in a building creating 2 or more areas. Can be on 1 floor or multi-story. So this is how so that's the definition of a fire area. Occupancy separation. In order to be considered a separate occupancy, each occupant must be separated by a fire barrier or horizontal assembly. Different occupancy types may require the separation based on risk factor. Restaurant and retail shops, and we just looked at that, you guys, just now, right? We just looked at that. So that's when you're trying to separate each other from different groups of people. Now, a tenant separation, something you might see inside an office, like so tenant separation, also known as a demising wall, shared walls between 2 different tenants, like if you're in 2 offices and you have a shared wall. If you have business next to business, there usually has to be no rating, okay? So treated as occupancy separation, but you look it up at the chart and you have to see, well, what does that look like? Demising walls are something that are partitions that a lot of times designers can place them in spaces as long as they're not load bearing. So they separate your offices between each other. Dwelling and sleeping units separation. So that's our occupancy. Required by code to be separated by a fire partition from shared walls. Dwellings such as a hotel, dorm, or apartment, at least 1 hour. Aren't you glad that your hotel room next to you has an hour fire like rating? Like you don't know what they're doing in there, right? And so that's really important. Okay. Now, incidental use. Certain rooms within a building that pose a safety threat may need fire separation walls, such as machine rooms, laboratories, boiler rooms, laundry rooms. Okay. Now, we talked about that when we talked about incidental rooms versus accessory rooms. And I don't know if you guys remember that, but incidental rooms always are more risk and usually have an hour or a protected fire rating. Let's say it's the laundry room, it's a boiler room. There's things and it's inside of could be a little lab inside a classroom. So it's also something that has to be protected. And then vertical shaft enclosures. Vertical shaft enclosures are the exit stairwells. elevators. Okay, they're vertical shaft and go from floor to floor. So, and they're enclosed. Okay, so those require passive fire protection as well. So these are all the areas that require passive fire protection. Um, when you look through here, right here, these are just simple little wall. So this one has a sprinkler location. So second floor room, let's see, egress hall, also sprinkled. So this one has sprinkles. So that is not passive, that's an active. I'm here, all of these red walls, fire resistant rated units, separated walls. So these are at least an hour, okay? And they're separating from each other. So this unit condo and this one and so forth. So there you really see those fire separation walls right there. Usually exteriors have to have 2-hour rating. Okay, here, if you had like a two-family solution and you're separating one condo from the other, you would need, once again, that fire resistant separation from the ceiling all the way to the very bottom of the floor. Okay, so that's what we're talking about. And so there's different kind of separations and occupancy separation, tenant separation, dwelling separations, incidental separations, and vertical shafts. Okay, so here is another kind of passive protection, incidental rooms. So like I said, certain rooms within a building that pose a safety threat will need some extra separations, which like machine rooms or labs or laundry rooms. You can find those in a code. So if I had, let's say, a room with a boiler where the largest piece of equipment is over 15 PSIs, okay, pressure per square inch. So it's like pressure, and 10 horsepower. It's very specific. I would need a 1 hour or provide an automatic sprinkler. So either you give me a 1 hour firewall or I need a sprinkler. But let's say I had a furnace room, any piece of equipment over 400,000 BTUs. I would need, once again, a 1 hour fire or 1 hour or provide auto or sprinkler. So as you go through here, you'll see different things like a print shop or an incinerator, refrigerant machinery room. And some of these are just very, abstract. And these are found over in 509. We investigated 508.4. That showed us the hours between different occupants. This one has everything to do with incidentals. Okay. And it gives you exactly, what room is what. And you guys are going to have to look some of these up when you're looking at some of the rooms here, okay? Like, oh, what is that room? When you find out what that is, if it's, and I think maybe the trash room might be an incidental, like an incinerator trash room. So that will be interesting to look at, okay? And I'm not going to get on the, where it is, but it's right there when we click on here under the heights and areas right there in 509. Okay, more stuff. Now we're going to talk about those vertical shafts, which is things like the stairwells and the elevators, dumb waiters. That's like a vertical shaft, right? So vertical shaft enclosures are vertical openings of a building that may extend from the whole height of the building or through several floors. Might not be the whole thing. These openings add risk of fire, smoke travel to various floors. So they may need to be enclosed based on risk factor and codes. These protected enclosures are considered a type of a shaft. So we call these vertical shafts, anything that penetrates from floor to floor. Fire barriers are required to enclose elevators, dumbwaiters, atriums, exits, stairwells, and shafts for building systems. Determined by the number of floors they penetrate, typically 1 to 2 hours separated is required. So when you're in a separate, a vertical shaft like an exit stairwell, I can guarantee you it has at least 1 hour fire rating because it's required. So here is kind of like what we're looking at, the 4 letters of fire. Okay. And we'll watch this little video and then let's see what time is it. Okay, so means of egress. Okay, we're going through this. You guys are going to do this to your drawing. You're going to be able to identify after this lecture what wall like that needs to be, What kind of fire rating does this need to be? How about this mercantile between the restrooms? How about this exit? What about these two walls? Do they need to be fire rated? You're going to go through on your space, and every wall that I dictate, which is the private suites and just the corridors, you will give a tag number to and tell me what our fire rating has to be. Okay. So it's kind of fascinating. It's there in the chart. You kind of look and you get, but that's kind of what we're doing today. So here we're going to talk. So everything that's clear is an unrated wall. So within this business building, these are little demising walls. So they're all unrated. They're just, Joe's the cubicle next door and you're there. This is within an office. So those are all unrated. The ones that are black are rated. Okay. And we're seeing this. Okay. And we're seeing different things. We're seeing rated walls around stairs. Okay. We're seeing rated walls between different businesses, rated walls in corridors. Okay. The women's and men's restroom pose apparently no threat. So that is not rated right there. Okay. So when you look at the black, you see all the ratings. Okay. And this is how you know. So here it says exit stair. So it's rated. An exit passageway. So it's fully rated. So the moment they walk in, this is all part of the exit system. Okay. Exit access corridor within tenant space. Here's a little corridor just inside the tenant. It's not rated at all. That's just inside a large office building, office. Okay. Exit access corridor and area of refuge in the public space. Okay, well, that is fire rated because not only it's the area of refuge making it needing to have some kind of fire rating, this is where everyone comes out to. So it has a rating. Now, probably less than this, but it has a rating. Horizontal exits right here, all these. Okay, whenever, this is a key, you guys, whenever a door or any type of penetration is on a fire rated wall, that element must be fire rated as well. That is a number one rule. If the wall is rated, all assemblies on that wall, windows, doors, all have to be rated. It's the rule. Okay. So you see that these are rated. Exit access corridors and area of refuge and fire too. So this also is another section, a different building here. Okay, that also has to be rated. Exit stair with the area of refuge right here, and that's all rated. Okay, so we see that within this building, there's different colored walls or different ratings, and we're going to learn what is what. So stairways. Walls that enclose the exit stair must meet the same requirements as a vertical shaft, because that's what it is. Typically 1 for 3 or less stories and 2-hour rating for 4 or more stories. Okay, so I believe that your guys' building is 6 stories high. So the building that we're working on now, I gave you guys some content about it. If it were 6 stories, how many hour rating would the elevator have to be? Or I mean the stairs. If it was 6 stories. 2 hours, exactly. And that's why you need to know information about the building. What building type it is, how many stories it is going to dictate the rating. Okay. Now, must also be smoke proof and serve as an area of refuge. So these areas people can hang here. Okay. They all need to have, now if this is less than 3, it's 1, but let's say it's not. Horizontal exits, which are those rooms that we talked about, used to provide alternate means of egress within a building with the use of a fire barrier to provide the protected exit to another space, typically 2-hour separation and door assembly rating. So like I said, let's say that this was an assembly room, this whole thing would have to be a 2-hour fire rating. It's part of an exit system, but they stay. They don't really leave. They get rescued. Then that area of refuge, we talked about those guys. They could be in your stairs. It could be an area of refuge in a corridor. An area of refuge, what we call defend in place, means the egress must be separated by a smoke barrier that provides a fire resistant rated wall of 1 hour. Area of refuge can be in other exits and must follow the most stringent code. And then corridors. Exit access corridors are corridors that lead to an exit. Rating ranges from a half an hour to an hour. Need occupancy, class, load, sprinklered or not sprinklered. So all of that, whether or not this corridor and this one needs to be rated, is based on occupancy, class, load, if it's sprinkled. So that, and so that's what tells us what that is. So we're gonna watch this video, probably take a little break, and kind of get the gist on all the different types of wall ratings. So it's close. Did we already see this one? Maybe we already watched it. We may have watched it. Let's see. Oh, no. Just taking its time. Come on. If we can move it.
Required between one occupancy group and another.
Let me see if I can, wait.
Have you ever wondered, how do you know if there's a separation required between one occupancy group and another? And if so, how many hours are required for separation between them? Or moreover, are they even allowed? Is one occupancy group even allowed to be next to another occupancy group? If you have, we're going to give you some answers today. So don't go anywhere because you're about to find out.
You jazzed it up a bit. It's a little more jazzy.
Hi there. My name is Josue Diaz. I am a licensed architect in the state of California, and this is ArchiCorner episode number 32. In this episode, we are going to be talking about separations between occupancies, whether they're allowed to be next to each other, if there's a separation requirement, how do you find all that stuff out? But first, just to make sure everybody's on the same page, this video is based on codes in the United States, specifically the International Building Code, or the IBC, as it is commonly referred to. Second, we're going to be talking about occupancy groups. If this term is unfamiliar to you or a new concept, there's a whole nother episode that has been made that talks about this. If you're watching this on YouTube, it'll appear somewhere on your screen now if you want to link to it. It will also be in the description below. And third and last, when we're talking about separations, we're talking about a fire-rated separation, more specifically a fire barrier. If fire barriers or firewalls, if that term is all new to you, there's also another episode that talks about this. And if you're watching this on YouTube, there's going to be a link to it somewhere on your screen. It will also be on the description below. So now that we have that out of the way, let's get right into it. You'll actually find out that it's quite easy when you look at the tables that are provided in the IBC. Specifically, if you look at IBC table 508.4, titled Required Separation of Occupancies, you're going to see a table. In that table, you're going to see the occupancy groups listed on the top and the side. The table is also specific as to whether the building has a sprinkler system or not. Once you know what groups you have next to one another, and if the building is equipped with a fire sprinkler system or not, all you have to do is see where they intersect. For example, if you're working on a building that has a sprinkler system, and if you had a B occupancy, and you wanted to place an A occupancy next to it, then you would find B occupancy on the top, and then be sure to use the column for sprinkler buildings. Then you would find occupancy A on the side, and see where they intersect. This will let you know what is needed. Notice that when you look at this table in real life, this entire table is going to be populated and you're going to see a whole bunch of other numbers. But to make it clear and avoid all complexity, I've cleaned it up so all you see is what we're talking about. The letter or numbers in the table are important. N stands for no separation requirement. That means that you can have them next to each other without a problem and without any fire barrier between them. There's also numbers 1 through 4. And if you see a number here, that means that you need to separate the two occupancy groups using a fire barrier. The number tells you how many hours the fire barrier must be designed for. And lastly, NP. That means that it's not permitted. And you will see this a lot with hazardous occupancy groups. But that is it. It's quite simple, right? I mean, it's just a matter of looking at this table, seeing where they intersect, and that's it. It's not rocket science. However, did you know that even if this table states that you do need a separation between two occupancies, there are exceptions? It's possible that somebody may just look at this table, go through one occupancy, look at the other, and say, oh, we need a separation, and just provide it. But there are exceptions. Do you know what those exceptions are? It would be very helpful to know, because imagine the money that you could save your client if they don't separate, or if, in other words, they do not have to build a fire barrier between the two occupancies. There would be a savings in cost for the actual construction of the wall, but there's also penetrations that have to be fire rated or protected, like mechanical ducts or electrical conduits, equipment. There's a lot of stuff that could be going from one occupancy to the other. So it's actually very costly at times to have to provide a separation. And that is the difference between a good architect and a great architect. If you want to know about these exceptions, keep an eye out. There's a couple more videos coming out that will show what these exceptions are and what the building code requires in order to allow for those exceptions. If you like this video, please give me a thumbs up. It always helps. Also, don't forget to subscribe if you haven't. If you feel that this type of content could also be of interest to someone else, please share the video with them, share a link. It does help a lot, believe it or not. It gives me that extra push.
Okay, so kind of giving you, it's right there in that the particular code you can look up and find out what you need. I just showed you. Now this is kind of a great little 4-letter word fire. It helps you. So F, first access. So public corridors. How did you get to the space? So that's the first thing you think of, like, how did you get to the space? So those are usually fire rated, how you get to the space, the actual physical space. I, into and around the space. So that's the tenant, the demising walls. R, really big meeting rooms. Assembly spaces over 750 square feet. Those are required to be also fire rated. And then E, everyone forgets about large storage rooms that are larger than 100 square feet. So these are little, like, just to know that, okay, these are going to be fire walls, or where you're going to put fire protection. FIRE, the first access that you get in into the tenant and demising walls. So once you're in there, you start to realize, okay, does that have to be protected, this business and this business? Really big meeting rooms, like they said, if it's over 750 square feet. And then large storage spaces. These are just little tricks that we learn when we were studying for some of the California test. It helped. Okay, so we're gonna kind of get into this, but right now it's about 18 till. Let's take a break till 4, and then we'll come right back, and then we'll finish up where we started. Okay, you guys. Thank you. See you soon. Hey, everyone. I know breaks are so short. Okay. Has anyone, did anyone come in late and didn't get called that I didn't, because I did took roll. Please let me know if your name didn't get called. Okay, great. Okay, we're gonna start sharing. Let's people kind of cruise on in. Okay, let me start. Okay, hopefully everybody's back on track. Let's finish up this. Okay. So we just went through these different little areas of passive where passive fire protections need to be. And we're talking about a little bit more of now some smoke barriers. Okay. Um, Smoke barriers, what are those? Smoke barriers are continuous vertical or horizontal membranes such as walls or floors or ceiling assemblies that is designed and constructed to restrict the movement and passage of smoke and must be sealed completely at all joints. So smoke barriers are these more stringent, okay? He was talking about that in that little video. But you've got to make sure that if you have a smoke barrier, you are sealing everything. Now, smoke partitions, they're lesser degree of protection than a barrier. These are a wall assembly that is designed to form a barrier to limit the transfer of smoke. So some really restricted, others just limited. Smoke compartments, what are those? A space within a building enclosed by smoke barriers on all sides, including the top and the bottom. So it basically traps it in a compartment. Okay, it kind of holds it there. Vestibules and lobbies. Some must be smoke proof, such as an elevator lobby adjacent to an elevator, a hoistway, or between the stair shaft and an exterior exit door. Doors must all be fire rated and self-closing with a drop sill to seal air leakage. And that's an interesting thing. The sill they drop actually. So once it heats up, it automatically drops, or it even does creates a foam, so it completely seals in a space. So these are some of these passive smoke barriers, and we're looking at this here. Let's look at one of these walls. So here they have an hour fire resistant rated floor assembly. Okay, and they also have an hour resistant another so there are two floors, of course, like, because it's the next floor. So here's the ceiling work, here's the floor, so floor to floor. So they're both rated. Okay. Well, this is the key. So suspended ceilings. So let's say you have these little suspended ceiling tiles, which most offices do, and a little air duct. This is why this is a nightmare. Okay. I just want you guys to know what a nightmare and how hard it is to do smoke barrier and smoke partitions. How many penetrations do we have in a ceiling? We have HVAC, we have electrical penetrations, we have electrical ducts coming in, we have all this, and all of this ends up having to be so micro sealed when it goes through into the other space. This is why it's extremely expensive. And that architect that we just did that little video, he says a good architect can circumvent that because of the cost factor and if you can get around it. This is why sprinklers are such an advantage. But let me show you. So here they have an hour rated wall assembly, floor and ceiling. Here's the duct penetration, right? So that duct isn't opened into this space, but there's a little smoke damper, okay? And so it literally that little piece helps to control the smoke or any penetrations that can go into the space because it's open here. So there's a lot of little, you think of all those penetrations and how everything can travel and how it has to be controlled or monitored. So while you guys are sleeping or just sitting in your classrooms, there is a passive smoke system built into that space that protects you. It's a beautiful thing. And we kind of went over this earlier, but once you have a rated assembly, everything in it must be fire rated. So the doors, the glass, and we talked a little bit about these doors, and I kind of mentioned this before. So, and there is a code, and it shows you that if you have a 1 hour fire rated wall, how much hour rated does the door have to be? So there's even that code. Okay. So we're going to talk about some of these openings or protected openings. Okay, definition, a rated assembly that prevents the spread of fire or smoke through an opening in a rated wall. Okay, rated door assembly. Okay, typical door assembly has three main components. We kind of went over it. It's got the door, the frame, and the hardware. Okay, for a fireproof door, the whole entire assembly, it must be rated and tested as one complete unit. Okay. If a wall, listen to this, if a wall is rated, the door and the frame must be rated as well. We're going to look at that table. Okay. So any one of those walls, when we go up here and we look at this, anything that's a rated wall, this is rated then. This is rated. That is rated. That is rated. That is rated. Okay. These aren't because they're not in, well, that one might be, but if they're, that's part of a fire, so it's rated. So you have to really pay attention, and that's why you need to know what the wall is. If a wall's rated, then you have to, the whole thing has to be rated. Must pass NFPA 253 or 252 or UL 10B, UL 10C. So UL is that underwriter's laboratory. And like I said, when we look at a door, if you open up one of these doors, maybe it'd be here underneath the sill area, you would find a little plaque on it. This is what the fire department will come in and, if he wants to check and make sure you have the rating, you have it rated. So UL is the most common here, and it tells you that this is what the door rating is. It'll fill it in and give you the hours. Here, this company says that this door is a 20-minute rated door. Okay, so it's got one of the approved seals. So all of these elements are part of it. And I showed you guys the website on, I think it was two lectures ago. You can see all these different components. But here, like we said, this is a closer, an automatic closer. It's at 78 inches above finished floor, and it automatically closes that door to shut it up. The glazing, this hardware, this has to be fire rated. Usually has metal in it, sometimes metal wire. It used to be able to be 240 square inches, and now it can only be 100 square inches, so it's even smaller. All of this has to be rated, all of these components, the push bar, and every element on the space. So lots of things. So you say like the label could be, it's got to be in the, and the whole door jamb, the entire door jamb has to be rated. So they're showing the labels on the door jamb, and then also on the doors themselves. There's the door closure right there, the smoke and fire seal. So that little thing this is sealed for smoke and fire. The frame has to be rated. The visual panel, like I said, has a code. Has to have usually has some kind of kick plate that you can kind of, maybe it's metal right here or the whole thing steel. Thresholds. So when this thing closes, you guys, this little threshold seals shut so the smoke can't even go underneath. Okay. Sometimes it's sealed with a foam, and it foams. It's really interesting. It activates and foam goes there to completely seal it. The lock and latch or the push locks all have to be sealed. Okay, so this is what we're looking at. The codes here, and this is in 716. If we look here, I'll show you. 716. Let's go look at what the rating is for doors. Come on. I don't know why this has been so laggy. Let me just see if I can go to there. Yeah. Okay, so we're going to go to 716. And here we have this little guy, okay? And it talks about different wall ratings, and let me look at the right penetrations down here a little. Just a couple. Remember I told you about the door visual panel, the glass, you guys? So all this is blue. It can only be 100 square inches. Okay, it tells you that the size of that. They changed that a couple years ago. So that's all about the glazing. This one, it talks about, let's see, this one, fire window assemblies. So it'll tell you with the fire partition in hours for windows. Okay. And then I think that there's another one coming up. Smoke or draft control, let's see. Where is that? Did I pass it? Did I pass it? Okay. It has like if your door, like if your wall's an hour, then you have to have a 20-minute door. Or if you're all out walls a 2 hour, you have to have 75-minute or 3/4 of an hour. So trying to figure out where maybe we passed it. Anyways, but you could see that it talks about the glazing, safety glazing. It gets into other different elements. This is windows. Is this my doors? Here is fire protection opens these ratings and markings. And okay, sorry guys, I don't know where, it's probably in a different one, but that kind of gives you an indication. I may have passed it up. It's 1.1. Okay. So when we want, it gives you just all the criteria. I'll probably go to the different one. Okay, now let's talk about these windows as well too, because it's right there in that area. We just talked about this little area, these little areas, and all of the various components that have to be fireproof. So, and oh, maybe this is going to take me to the right chapter. Okay, so passive opening protections. So once again, these are integrated into the space. There's nothing you have to do. They do the work for you. So definition, a rated assembly that prevents the spread of fire or smoke through an opening or a rated wall. A fire window assembly consists of frame and approved rated glazing. Now, glazing is another word for glass, okay, or the window, okay? So we in architectural terms called glazing. Okay, can be part of a door assembly, maximum 100 square inches per code. Like I said, that's 100 square inches. Must pass the NFPA 257 or the UL9 test. So you have to make sure it's met that requirement. Rated glazing and frames protect against fire, smoke, and radiant heat as well, and is given a fire rating of protection. Fire resistant and resistant impact too. There's a bunch of different tests. It checks like if a fire hose hits it, will it not break? So it has to have impact resistance. It has to have shatter resistance. It's very interesting. So here you see, and we're going to kind of talk to you. So so it says fire protected glazing under 25% of the wall area. There's also a code. If you have a fire protected wall, you can't have more than 25% of that wall windows, okay? Because it makes it too compromised. Maximum 25%. So as you're designing and stuff, you start putting all these windows and you realize it's a fire protected wall, you have to literally do the math and see what square footage is windows. If it's more than 25%, you have to either make your windows smaller or omit them, okay? Because it can affect the integrity of that wall. Fire resistant glazing, over 25% of the wall. So so if you have fire protected glazing under fire resistant, you can have over. So there's different kinds of glass. So let's say you need more of a curtain wall, then you have to change your glazing. Now this little UL, and it'd be interesting if you guys all go to one of your, I don't know, task lamps in your house, or just a regular just a light fixture, and look at it, and at the base of it, you'll see this little UL sticker, okay? Tells you what wattages you could use, and it has a code on there. You cannot sell or operate, supposedly, you cannot sell any lighting fixture in the United States unless it's UL rated. Okay, that's a code. So you have to be very careful, you guys, when you are specifying lighting from other countries, like China and stuff. Because if it comes in and it's not UL rated and it catches on fire, that's on you. Okay, there are certain ratings that especially for commercial spaces, you have to have UL rating. Every one of your line fixtures, I'm pretty sure would have this little silver sign on it. But what does it mean? So each one of these words has a different meaning. Okay. So the overall, this is the whole UL certification, tested and complies with the current building regulations. So this is a little, D, what does D stand for? Meets fire door assembly criteria, UL 10B or UL 10C. So the D stands for door. So if you're trying to go, what is this for? Then you look at the H. H, fire door assembly. This is hose stream. So it tells you that it passed the hose stream test. Okay, that's another test. Okay, regarding a fire hose, and 10B or 10C. The NT, what does that stand for? Okay, the T or NT defines if glass meets the 450 Fahrenheit temperature raised criteria for 30 minutes. That means it can handle that amount of temperature for 30 minutes. And that also passes. So that's what that stands for. Okay. Now we go to OH, and that meets fire window assembly criteria, including the hose stream test again, which is UL9. And that's an interesting test. They kind of talk about these tests when you're studying the NSIQ. Also, this number of minutes. So when you want to know, is this the right assembly? I need a 20-minute door assembly. This tells you the minutes. This is telling you it's a 45-minute assembly. So this is good for a 2-hour door. So 20 to 180 minutes, the product of the fire protection rating minutes in UL. So this is a lot of information. It's for a door. It tells us if it meets the hose stream test. It tells us that the glass meets the temperature test. It also tells us about that the window itself meets the hose test and the number of minutes. So it's really interesting what you can learn just from the little sticker. Now, we were talking about fire protection versus restricted rating. And when you have one that's restricted, you can have more glass. You can have more than 25%. Why is that? Well, if you just have a fire protected glazing, it says under 25% of the wall space, you can see right here that heat still penetrates on that glass. So all that heat is radiating and can eventually just explode. Okay. So that's fire protected rated glass. But if you have fire restricted rated glass, that heat comes in and it bounces right out. It literally can handle all the radiant heat. So that's why you can have more of those windows or glazing. It's because of the type of rated glass. Okay, the restricted is far more stronger than the just the protected. So we're going to talk a little bit about different kinds of glass. I'm sure that this looks familiar and the different kind of things. So these passive openings, we're still talking about it. So definition, and I do remember in the test, they made me define the different kinds of glass and what they're for, like laminate glass, tempered glass, and stuff like that. So you have to be kind of familiar with this, especially for the fundamentals test. There's 3 parts of it. So definition, a rated assembly that prevents the spread of fire and smoke through the opening of the rated wall, right? So fire window assemblies consist of the frame and the approved rating. We just talked about that. Can be part of a door assembly, like I said, only 100 square feet. Must pass this NFPA 257 or UL9. Rated glazing and frames protect against the fire, flame, smoke, and radiant heat. Just like radiant heat, and is given a rating of fire protection, fire resistant impact. So you can see that it protects from those things. Various types of glazing, you guys. Wire glass. See this right here? Okay, so wire mesh sandwiched between 2 pieces of layers of glass. It adds strength to it. A tempered glass is thermally treated to alter the way it breaks, and it's 6 times stronger than wired glass. So if you're going for tempered glass, fully tempered glass, it is extremely strong. And it is the type, have you guys ever broke a windshield? When the glass turns into little beebles, like little pieces of glass, but it stays in there, it doesn't shatter in shards. It breaks like little teeny balls inside. That's tempered glass. Okay, once again, 6 times stronger than this wire glass. So tempered glass would be a great type of glass. We have that in our cars, on our windshields, so that if a rock hits, and they don't, break the same way. We don't want shards. Tempered glass in your shower if you fell. Glass block, limited use for 1 hour rating wall. So you can't put this, you must have a 1 hour rating wall. Clear ceramic, high resistant to heat, impact, thermal shock, and host test. So there's a thing called ceramic, heat strengthening glass that is called clear ceramic. And then laminated glass is two pieces of glass laminated together. So each one of these all have their own different fire rating. If you want the strongest, I would say the tempered glass is the strongest. And they have different, but the clear ceramic has a high resistance to heat. So it just depends on what your wall is, what you can use. You might have to specify this someday. Okay? Probably never thought you'd be specifying the glazing in a fire rated wall, but you never know. You never know. Okay, so now we're done with all of those assemblies. Okay, those things that are pre-assembled, they put in. Now we're going to talk about when you have a penetration. And you're thinking, what does that have to do with me? Like, but once they break into the wall, right? They got wiring that's got to go through, air ducts, all kinds of stuff. What do you do around that area? Okay. And so here is a solution. Okay. This is a lot of work for things like this. Okay. So we're going to talk about that. You have to seal them up. Okay. So definition, opening that pierces the entire thickness of a construction assembly, such as a wall or floor ceiling assembly. So what are fire stops and fire blocks? I know this is so exciting, but it's important. Oh, okay. So fire stop and smoke stops. Okay, they restrict the movement of fire, heat, and hot gases through openings made in the fire resistant rating wall and floor, ceiling, and roof. So we got a lot of openings going on. This is why it's super expensive. And you as a designer can't just start opening up walls or putting a new, I don't know, a new outlet or something. You have to be really careful. So fire stop. So seal and protect any openings created by penetration, such as plumbing pipes, electrical conduit, and HVAC, right? You've got to seal it. You use fire stops and smoke stops also for use of damming materials and non-combustible sealants such as fire-rated caulking, silicone foam, mortar, a mineral wool, and mesh are used to seal penetrations along the collar, the sleeve, plug-ins, and clamp bands. So that's what this is. So a fire stop or smoke stop, this is a band, and they literally pour in a putty in there, and it completely seals it shut. So when we're talking about these fire stops, these are things that we use to stop the fire. Usually they're in some kind of collar, so that or a threading, and you're able to literally seal that whole thing off. So this does not spread in here. Very expensive, and it takes a lot of time. Got to engineer it. Now, fire blocks and draft stops are used to restrict the spread of smoke and fire through concealed space. And we'll talk about that, like in the plenum of the ceiling. So fire blocks use building materials to prevent the movement of air and flame and gases through small little concealed areas. And draft stops are used for large concealed areas. So the fire stops are used to stop up the fire. You think about stopping up the sink or stopping up the toilet. Think of that, fire stops. They literally plug it in with some material, whether it's silicone or cement, grout, whatever. So the fire blocks are things that help to block and isolate movement of fire. So we think about all these different things. So passive, so penetrations. So when we start talking about fire blocks and fire stops, okay, obviously they're used to stop smoke spread. But fire blocking, we just went to fire stops. Fire blocking uses building materials to prevent the movement of air, flame, and gases through small concealed spaces. And so and then draft stops are used for large spaces. So when you see things like, let's see, okay, I want to look at a fire stop. Okay, so, okay, I'm trying to get my bearings here. Okay, so when you have a like fire blocking, it's like added extra pieces of construction material to trap in the smoke. So something like this would be fire blocking right here. So you've furred out and you've put fire resistant material in between these horizontal pieces. You know, we hear the word blocking is a support piece, but you can actually add fire treated pieces of support piece to trap the materials in there. Okay. And it gets kind of complicated, but concealed spaces in a stud wall, you might find it in partitions, including furred spaces, parallel rows of studs like this that are staggered, vertical at the ceiling to floor. They're usually from ceiling to floor. They could be horizontal too. And they basically block. They like are there to, so the fire comes in, hits that blocking, and it stops it. It's a fire resistant piece of material. So this is kind of a lot of weighty stuff, but I'm going to move on. You guys can look at that more. This is a little bit easier to look at. We're going to watch this because we're going to talk a little bit about fire dampers and what they do. So the fire blockings are pieces of construction material that isolate elements. But the fire dampers actually are mechanisms that close and open and have internal mechanisms that help them to conceal fires. So I'll read this, we'll watch this video. Definition, okay, so fire dampers are used in HVAC penetrations at ductwork and air transfer openings. So you got all this air coming in and out, and from one space to the other, it's the perfect storm kind of nightmare. So how do you get the HVAC in a 7,000, or 7-story building? So the device automatically interrupts the flow of air during an emergency and restricts the passage of smoke and heat. And there are two types. We're going to watch the video. A fire damper required in the ducts and penetrated rated walls, and a smoke damper activated by smoke rather than heat required in the duct penetration at a smoke barrier. What it is when you have all of those air ducts, you guys see them, there is something in them that closes them automatically. Once the smoke hits, it closes it. So it keeps it from penetrating into your space. So that's what kind of a damper system is. It dampers and those fins close it off. Okay. So you see this like ceiling damper, and it will close off the smoke getting in. And we're gonna watch this little video. So it kind of tells you the difference. There are a lot of things happening inside walls.
Hello and welcome to Archie Corner. This is episode number 44. In today's episode, we will be discussing fire dampers and smoke dampers. We will also be discussing where they are required for the 2021 IBC. So let's get started. To begin with, I want to show you one example of a typical building, and then we will go from there. Here, we have a building with a mechanical unit on the roof. Normally, there are more than one unit, but for this example, let's just look at one unit. This unit has a supply duct that supplies air to the space, and also a return duct that returns air to the unit. There are different ways on how air distribution would work, but for this example, we will assume that there will be ducts that branch out and terminate with air diffusers that supply air into the space. As for the air that will return to the unit, the duct may terminate here, and the suspended ceiling may have return air grills that do not have ducts above. Due to the pressure that is created by the air that is being supplied to the space, the air will find itself a way back through the return air grills, through this return air plenum, and back to the return duct. And just bear with me, but let's assume that there is a fire-rated wall at this location. The supply ducts penetrate the wall to supply air, and then air transfer grills would be provided at the suspended ceiling, as well as an air transfer opening in the wall, which is basically a hole in the wall. This will allow for the air to return to the unit. But remember, the whole point of a fire-rated wall is to prevent a fire from going from one side of the wall to the other. If you have not seen my video on fire-rated walls, you can check out episode number 15. So what happens if there is a fire here? Well, if we leave the openings and penetrations unprotected, over time, smoke and even the fire could jump from one side of the wall to the other side of the wall because the duct is creating a weak point in the fire-rated wall. Not to mention this air transfer that is also a big problem because it's just a big hole and smoke and fire can easily go through. There's also the chance that the smoke will travel through the air plenum above the suspended ceiling and into the unit by means of the return air, and then the HVAC unit would be spraying the smoke everywhere. You can see how this is a problem, and this is where dampers come into play. To understand what a damper is, let's read the definition of a fire damper. We can actually find the definition of dampers in Chapter 2 of the IBC. If you look at the definition, fire damper is defined as a listed device installed in ducts and air transfer openings designed to close automatically upon detection of heat and resist the passage of flame. Fire dampers are classified for use in either static systems that will automatically shut down in the event of a fire or in dynamic systems that continue to operate during a fire. A dynamic fire damper is tested and rated for closure under elevated temperature airflow. So let's break this down. First, it says that a fire damper is a device that is installed in ducts and air transfer openings. So, if we go back to our example, let's clean some of the things here to make this a little clearer. A damper, as we read, would go in our duct here and in our air transfer here. Going back to the code section, here it says that if they detect fire, then they will close automatically. To explain how that can be accomplished, let's look at a larger version of a fire damper. This is a section of a fire damper in a wall. Under normal circumstances, it lets air go by just fine. Fire dampers have a little metal strap right here that is held together by a fusible link. While the fusible link is in place, the drop-down screen remains in the open position to allow the air to flow through. But in case of fire, the temperature will rise, and when the fusible link gets to a certain temperature, it breaks and the strap opens. Once the strap opens, the screen drops down. And once the screen has fallen, it shuts the opening and therefore preventing a fire from going to the other side. By the way, just in case this wasn't clear already, let's go back to our building diagram for a second. The damper can be installed as part of the ducts, and it could also be in the wall as a standalone for the air transfer. Going back to the code section, the second part of the definition mentions that there are such things as static systems and dynamic systems. I am not getting too much into this other than letting you know that most air distribution systems, for the purpose of providing heating, venting, and air conditioning, are usually static. As applicable to this section, dynamic systems are systems that usually assist in exhausting air. As a very brief example, let's assume that we have a fire-rated wall on the second floor. Let's also assume that we have a ducted exhaust that just exhausts air out of the building. In case of fire, this could be engineered so that it helps to exhaust smoke out of a building as part of a very carefully engineered system. You can see how you would want the smoke exhaust to work in the case of fire. So if the building is designed to work this way, you would need a damper that is part of a dynamic system, not a static system. You would not want a damper to close in this scenario because the exhaust allows the smoke to get out. Okay, that is all that I will say about that. But speaking of smoke, this takes us to a smoke damper. A smoke damper works with the same principle. The IBC defines a smoke damper in Chapter 2 as a listed device installed in ducts and air transfer openings designed to resist the passage of smoke. The device is installed to operate automatically, controlled by a smoke detection system, and where required, is capable of being positioned from a fire command center. So you can see that this is basically the same type of idea. The definition notes that they can also be in ducts and air transfer openings, just like the fire damper. This system operates automatically, and note that here it states that it is controlled by a smoke detection system. So let's explain this. In the same scenario we had before, if we were required to have a smoke damper at these two locations, a smoke damper would work similar to a fire damper. But to see the difference, let's draw up a section of a smoke damper like we did for a fire damper. The smoke damper will have fins that, when open, will allow for air to freely travel from one side to the other, just like the fire damper did. But the fins can be activated by a smoke detection system. When the smoke detector is activated on either side of the damper, the fins will rotate and stop the flow of air. Also note that per the definition that we read earlier, the smoke damper may also be positioned from a fire command center. So the same system may also be activated by a building system such as a fire alarm. So this is pretty simple stuff, right? Now, there is also a fire and smoke damper, which is basically both of these combined into a single unit. And it works like a smoke damper, with fins rather than a drop-down curtain, but it can also stop fire, not just smoke. Okay, so now we have covered the first part of the video explaining what dampers are. The next question is, where are they required? This is where it gets a bit tricky. The reason is that some areas require smoke dampers, other areas require fire dampers, and yet other areas require smoke and fire combination dampers, which, as mentioned before, is a unit that does both. So here's what I will do. I will let you know what the code requires, but for the specifics, you must read the code and find out more. But don't worry, I will let you know what sections to look at. So here is a table. On the left-hand side column, you can see the section that requires it based on the 2021 IBC. Then, the second column notes the types of walls that may need a damper. The other remaining columns will let you know what type of damper you need, a fire damper, smoke damper, or both. Note that this is outside the topic that we're touching on, but there are also corridor dampers and ceiling radiation dampers. If you want to know more about these dampers, just look at the code sections noted. Memorizing this table may be a bit complicated,
Good
but
thing
if
we
you
don't
become
have
a
to.
patron, you will be able to download this list so that you can always have it handy. I've spoken about fire-rated walls before, but in a future video, I will talk more about specific differences between firewalls, fire partitions, and fire barriers. So keep an eye out for that video. But for now, that's it on this topic.
Thank God we don't have to know too much about that. This is not my favorite. But you see, there's a lot going on. Kind of gives you a visual how he does it better than me. Okay, so there's some testing and rating. We're going to just talk a little bit about this just so you're aware of them. I've kind of mentioned some of these institutions. They get really specific sometimes in some of the tests that for California, some that you're going to need to know, but ASTM, I think it's American Standard Testing Materials, and then the National Fire Protection Agency, and the UL, the Underwriters Laboratory. Those three are the main like big fire testing agencies, and Nancy also. Nancy does a lot of other types of testing as well. A lot of it has to do with fire. Okay, they're the widest variety of standard fire endurance test. And then they have different ones. We're going to get a little into this when we studied one of the chapters on finishes, but they have different types of tests that they'll do. Test on walls and floors and ceiling assemblies to make sure that they meet the restrictions. Testing that evaluates the fire resistance of a material assembly and how a material reacts to fire. So they'll literally like build a wall and then with all the assembly. I mean, my gosh, this takes so much time. And then they have a controlled environment. Yeah. So evaluates the temperature, it evaluates the smoke, the gas, the flame spread, structural performance that's exposed by the fire. Test for opening and throughs, penetration protection. So they do a lot with the labeling with all the penetration type of elements that we talked about, those assemblies like the glazing, the doors, the anything, the door jamb. So there's a lot of different tests. These are the main companies that work on those. And you have to make sure that your assembly, matches the wall assembly. Really quick too, we're kind of talking a little bit about some of this passive sustainability. We don't dive into sustainability a lot, but we want to kind of touch on that. So these are some considerations when you are looking into this. So requirements that can affect the choice of materials. Okay. IGCC, that is the I-codes green, kind of green codes. We have them in California. They're called Cal Green. So Cal Green or IGCC, they work with a company called Ashra, and that's for heat. That has to do with air and heating and air, mechanical. So it's all about the air, the HVAC, Ashra codes. So there's a lot of codes about that. So, so when you're doing materials, you have to make sure that it says the IGCC with ASHRA codes may affect the need to select more sustainable materials with recycled content for a building. So sometimes you're a little bit pigeonholed and you got to pick materials too that are green. California requires tests to measure the volatile organic compound emissions. Those are called VOCs. So there's different kinds of things that we look into sustainability and testing VOCs, and that's something to think about when you are picking your materials as well. Green seal standards also might be required. So as you're not only doing some of these and picking out some of these elements, sometimes you have to look at the sustainability element of it. This is well standard. If you wanted to get a well standard building, it's kind of a certification. You have to hit certain criteria, okay? And Green Global, so they deal with a lot of energy efficiencies, site location, water efficiencies, indoor environment like the air quality, resources, and innovation. So we're kind of move on with this. We want to get to our thing. So, okay, so that's something to consider. Now, this is the worksheet, and we want to go ahead and we're going to look up some of these tables. They're already listed here in the ICC. And go ahead, and what you're going to do is you're going to look at the elements. So when you see A, you're going to see what rating it needs to be and what table it came from. Okay, so as you find A, let's find A. Okay, so this little wall. This is a demising wall between mercantile and business. Okay, I showed you earlier this actual table. Okay, and I said, okay, if you're into business and you are next to a mercantile, what number? So we have to find out. We are going to assume, and let's just see if they said if this is what is the, we got to get info. Okay, it's always important to read all the info. So this is a floor plan. It's 8 floors in a 10-story non-sprinkled building. So this is going to be a key for you, non-sprinkled. So on your worksheet, like underline that non-sprinkled office building. It shows the layout of the building core, 5 tenants, as well as the interior tenant space, this one. Okay. The tenants are either business, mercantile, occupancy plan. So you see this business or mercantile. They don't have anything else. They don't even have any assembly. So to keep it real simple. Okay. The legend at the bottom of the floor here, okay, of the floor plan indicates the name of each labeled room or space. Specified the wall assembly on the floor plan are labeled with critical letter designation, and certain door or opening protectives are labeled with a circled number designation. So all the circles here, you guys, are assemblies. Okay, so well, let's see. I'm sorry, with numbers. Okay, you'll see things with numbers. 5, anything with numbers here are some kind of penetration or opening. Okay, whether it's an elevator door, an office door. So the numbers represent over here, they represent the openings. Okay, number 1, 2, 3. So if you go to number 1 and you find number 1, this is an average door in a business building. Okay. And it looks like it has, and so you got to figure out, does that door need a rating? And you look it up. Once you find out what this wall is in the corridor, okay, every wall here is connected to something. You will know what kind of rating that is. So we're here, and what you want to do is you are going to tell me every one of these walls, A, B, C, is it a 1 hour, 2 hour, no rated, and what table you found it. And then you're going to tell me all of the penetrations, the doors, and anything, the openings, and if there are 20-minute, 3/4 of an hour, and what table you found it. Okay, and it's all found here. Okay, then we'll kind of take a look at that. So, occupancy load, we just told you what that, or we don't know what that, it has right over here. So you can see different occupancy loads. It tells you they're all pretty small. Now, this is occupancy load of 45, but it has two. And most likely because the path of travel is too long, the common path of travel to get to one door. So they had to put a second door. Okay. So I'm going to turn on a little music. I would like to see David and Jose and Alyssa and everybody turn on their screen and show me that they have this. Okay, this is studio time. Yeah. Give me a little love. Nicholas, are you around? Alyssa, show me you have a good. Yay, someone's already getting started. Thank you. Okay, awesome. Thank you. Okay. Say, Nicholas, can you think? So I'm gonna put a little music on. We'll spend some time just doing this. We don't get it done. Let's see. Yeah, well, this takes a little bit. So we got a good half an hour, 35 minutes we could work on it. If you don't finish it, just finish it up. Thank you, Nicholas. Do you have yours? Okay. Yay. Okay. You have the codes that are right there. They tell you exactly what ones they are. The second half is all of the doors and so forth. So let me. Okay. Awesome. I'm going to put a little music. Can you guys still see the worksheet or not? Can you see the worksheet?
Yeah,
Yes,
we
no?
can.
Okay, good. Thank you. Okay. Check off. I've got to stand up. My knee is killing me. I'm gonna turn off mine. I'm here. I'm just stopping my video so I can do a little stretch.
Never get bogged down with how much goes into being an adult. It can be a lot, but you know what makes all that feel a little less a lot? A perfect soundtrack. Take the work out of DJing your day and upgrade to Pandora Plus with unlimited ad-free music for every part of your daily grind. Tap to start your Pandora Plus trial now and check that off the list.
Feel like immersing yourself in the greatest rock riffs of all time? Come hang out on Pandora's Rockopolis.
Cool. Yeah, we'll stay and hang around with you.
Make your way to Rockopolis.
Hang out with us.
Sure you are. Just tap now, and we'll take you there.
How sweet. Sweet. Need shelter from one song. There you needed someone to understand my ups and downs. There you with sweet love and devotion, deeply touching my emotion. I want to stop. Thank you, baby. I want to stop. Thank you, baby. Yes, I do. How sweet. Feel so fine. How sweet. I close my eyes at night, wondering where would I be without you in my life. Everything I did just stayed for. Everywhere I went, it seems I've been there before. You, you're so sweet, so many ways. I want to stop. Thank you, baby. I just want to stop. Thank you, baby. Like sugar sometimes. Sweet. Oh, yeah. Thank you, baby. Oh, sweet. Like jelly, baby. For you.
Live in Las Vegas. Babyface, a night full of hits. Performing an exclusive engagement at the Pearl Concert Theater at Palms Casino Resort for 8 shows. February 13th and 14th, May 8th and 9th, September 4th and 5th, and November 13th and 14th. Get tickets this Friday at 10 a.m. Pacific at AXS.com.
Life moves fast. That's why California makes voting easy. You don't have to wait until Election Day. Drop your ballot at a secure drop box, visit an early vote center, or mail it. Over 80% of Californians vote early, and you can too. Plus, when you sign up for Where's My Ballot, you'll get a text or email the moment your ballot is received and counted. Don't delay. Vote today. Get more information at sos.ca.gov. A message from the California Secretary of State.
How you guys doing? Are you having problems finding these? Not too bad? Oh, how you doing, Mancy? Good? Yeah. I know it's a long one. How are you feeling, Alyssa? Yeah. Are you looking through it? What do you find tricky?
Um, just kind of figuring out the ratings and stuff for some locations. Like, I don't really understand what the B stands for on this
That's
paper.
business occupancy.
Oh, okay. I should know.
Right. So it says right here, it just tells you when you read this, it says you're dealing with only
Mhm.
business occupancy and mercantile. That's it.
Oh,
You got
okay.
business, and mercantile. So it's so easy when you look at the chart. You go, okay, if I'm a
Mhm.
mercantile and I'm next to business, I kind of showed you, does this have to have
Mhm.
a rating?
No, right?
Well, you're gonna have to look it up and let's see if it does on that chart. And then I'll say, does mercantile have to have a rating? Does business and mercantile? Well, you already know that. Then does business and business have to have a rating? Okay, see, they're all connected. So it's really important to know which ones are fire rating because what if someone hired you to design this space? Okay,
Mhm.
so we want you to
Yeah,
design this
it's nice
space,
to know.
but you don't know what the office is next door or mercantile and that you're penetrating a fire rated wall. Okay, you decided to, I don't know, put a nook there or add an outlet for a TV. And yet you've just now compromised this fire rated wall, you see? And you're gonna have to do that with that drawing we're working on. You're gonna go through the office suite itself and just the
Mhm.
corridors and the elevators, the common places, and you're gonna have to tell me what like a little tag, what rating they are. So that's why this is important. So this is business, that is mercantile. You should have asked me, just say, hey, all of these little walls within this little wall within the office, does that need any rating? So you have to look at business to business. Okay, so and that will give you all of that. That was pretty simple. Once you start figuring out that, then you start going into other spaces like a common corridor. Okay, so when they call out C, that includes this entire corridor wall. Okay, the whole thing. Now, if C has a rating, that anything on C, any doors have to have a rating as well. Okay, so they
Thank
have
you.
this door and this corridor wall. So that's another one. Is that 1, 2, no rating at all? Then you get into this is a elevator or this is a storage room. Okay, so you look up a storage room and it'll kind of give you the square footage. I talked about a storage room being over 100 square feet, and if it's over 100 square feet, and this is 150 square feet, often it needs a fire rated wall. So that's a little storage room. So you have to look over here and see what they stand for. This is stair 1, and we know this is an exit stair. So you look up and stare and see if it exits stair. And we talked about an exit stair. This would need a rating as well. Here's another exit stair. Now this is a trash room, a trash incinerator room of 120 square feet. That's an incidental room. So they have various, they have the different codes here. Here's one for incidental. Go to 509 and it'll tell you exactly where it is. It's also in your book too. They have it. And so you can look it up and see if the trash needs a fire rating based on the size. So each one gives you a little clue. Here's an elevator, okay? And so this is a vertical shaft. So it talks about that elevator 1, 2, and 3. Okay. Are you guys understanding this assignment? I want to make sure you're understanding that you're able to look at the wall and look at what it is. It's telling you down here. Okay.
I
And it's
think
giving you kind of
I
an
think
understanding.
for me, the biggest problem is maybe not so much identifying what's on the document, it's knowing exactly how to read the actual
Right.
chart, like
Yeah.
the table, and
Yeah.
know like like if you're saying S1 is
That's
exit
a that's
stair.
a vertical penetration and it's an exit stair.
So when you go to table 508.4, what is it like
So
that?
that's occupancy separation. Opening for fire protection assembly ratings and markings. There's different ones here. Corridor fire ratings. So each,
Okay, so we go to a
see,
different table for
they're
the.
different.
Okay.
Yeah. So it depends what you're trying to they're different tables. One
Yeah,
is
yeah,
separating them by occupancy.
yeah.
One is telling you about incidental rooms, corridor fire rated ratings. This one right here in 1012, totally in chapter 10. So it's a different, that's why they gave you all the different opening fire protected assemblies. And that tells you the, the doors and that sort of thing in 16.7. So that's why you have to look up. What we're going to do is we're going to probably close out, and then next week we'll pull this up and kind of go over it. That way you could see if you got it right. So do the best you can. Try to finish it up, okay? Because it takes a little time, and put it in the discussion, okay? But instead of rushing you guys, because it takes a little time, make sure you're reading all the instructions here, okay? It's giving you clues. It's telling you if, you know, little information, no table. You have to read everything on here, okay? The top is just the fire rating of the wall, and they gave you all the tables that should correlate to that. We also, I'm going to publish this PowerPoint, and you'll see that I talked about some of these vertical penetrations.
That helps when you you
Yeah,
publish
yeah, you
that.
can go back,
I'm
right?
gonna go back,
So
yeah.
instead of frustrating everybody, normally I meant to do you guys in breakout rooms. I'm so sorry, I spaced out. I'm in so much pain. But, and that way everyone can work on something else. But I want you to understand the process, because naming fire or doing petition tags is something that interior designers do. They actually mark all the petition tags. And so if it's a 1 hour partition or two, or what assembly it is. So I'm gonna, we'll go over some of this to, next week. The answers, we'll see why. And then we're going to, I'll go ahead and publish. Now there is an exam, y'all. So let me get out of here. Okay, and I believe that was the last. I'm pretty sure that was the last step. So when we get into the module, you have 3 days. Please set your alarm. Don't ask me to, I extended it last time, but I won't this time. It's basically everything that we've been learning so far. So study your worksheets, and I'm gonna go ahead and publish this so you can study the PowerPoints, and wanna make sure where we are. Okay. Right here. Okay, so um read a little bit about code compliance drawing. You guys are already working on this. We're going to start on project 1. This is where we are going to do things like identify all this stuff should be on your code compliance drawing. So we're starting to work on it. This isn't due for weeks, but these are the things that are on that first page. We have a cover sheet and code compliant. Identify occupancy type and square footage. You guys have already done that. Hopefully you're making it the occupancy load. You're going to put number of exits, the travel distance. These are that demonstrate the diagonal rule. So as you go through this is something that you should start perfecting on that original drawing from A5, A6, A9. You're like adding on to it. These are things that need to go on. Now, the partition schedule, fire rated construction type legend, I give that to you. So, but, and it has different little elements of what we put on it and where they go. We'll talk about that. Identify the required number of exits and the widths. We learned how to do that. If there's a dead end corridor, clearances, those 60-inch turning radiuses. So a lot of this you already have. I am providing you the assembly and the legend. So you'll have a place, and we'll talk more next week about how to do the partition tags, okay? So that is part of the big project, and you're working on it already. But that's going to be the code compliant, and we'll start to show what that looks like. Here is, but the exam, let's take a look. Gosh, which is so way down here. Okay. So the lecture right now, the worksheet. So this is, oh, that's for next week. So that's good. Yay. So basically, there is an exam too. It's due on the 25th. So please put in your calendar, if you have the 4 days or the 3 full days, it's worth 85 points. So it's a super, super important. Also, sending me, a lot of you send me the drawing progress of your space plan. Thank you. That allows me to kind of mark it up and then you make those corrections. So you are like really guaranteed, if you take note, to get an A on this project or a B, because you're allowing me to see it first and you're making corrections. So that's where this is a little assembly, a few questions on fire assemblies. So make sure that we get that 85. You're studying for that exam. I'm going to go ahead and do this for you right now. Okay. And I know it's a lot, man. Fire is so much. Next week we talk more about plumbing. We're kind of out of the fire scene, and we start to learn about how to how many fixtures, like how many toilets you need based on occupancy load and things like that. It's kind of interesting. But do you have any questions right now? So finish this up, put it in, study for the test. And if you haven't done your space plan, get that in so that I can take a look, see at that. I'm a little behind right now just because of this procedure, but I'll get caught up. Okay, email me, reach out if you have a question. Okay, you guys are doing fabulous. Please don't get too behind. It does kind of start to kind of where we do more studio and have time to actually work on our drawings and stuff too. So there'll be a little of that. Okay, have a great week and good luck on your exam. Okay, exam
Can
two.
you can you
David, do you have a
publish
question?
last week's
Yeah. Last week, that's what I was
lecture,
saying.
please?
Oh, I just did. I think I did.
Wait,
Someone had made a mention earlier that I didn't post it. I just did at the beginning of the, yeah. So I just
Okay.
I went ahead and I posted it, or I published it for you. Okay.
Thank
Do
you.
you have that? Yeah. You might need a refresh because I did it during class. Okay. Good. Well, good luck. You guys are doing fantastic. Learning a lot, right? Lots to know. Okay. Well, know that you're safe when you go into a high-rise building.
I have a question.
Yeah.
I did send the review of my drawing, but I know that you don't have the SketchUp program. So you said a lot of times like you can't see my like zoom in far enough to see the measurements.
Uh-huh.
So I just did a second zoom in of
Oh, thank you.
of the doors, because I was a little confused, because I know at one point you had mentioned it for us to maybe recess the doors in
Yeah.
and make that. So I was trying to follow what was given in the book,
Uh-huh.
the measurements and stuff. And then I did do one that was the 180-degree opening into the corridor, because it said as long as it wasn't deeper than the 7 inches,
Yeah.
you could have a door that opens that way as well. So I just put both in there because I didn't know what exactly you wanted, but I wanted to make
Okay.
sure that those were okay.
Okay. It's
Um,
very similar to the existing suite. The existing suite already has one. If you just
Okay.
mimic that exact door, like what it looks
Okay.
like, that would be great. It goes in it's 5 feet wide, it goes in 3 feet. And the door, you go 18 inches, there's the door. So it's like a little recess, a 5x3 recess.
Oh, okay.
Yeah.
Okay. So
And it's already in the existing suite, if you go look at it.
okay.
Yeah,
Okay.
so if you did all the doors like that, that'd be just perfect, because then you have no risk of infringing on the 44-inch corridor.
Okay. And then there was also that, I don't know if you got to it, I didn't check right before class, there was one of the discussions from last week that you had graded that I put in 2 separate files. So you
Oh,
were going to go back and look at that. So just FYI.
oh,
So
was it just a discussion?
yeah.
Oh, okay, okay.
You thought I was missing one, but I just had
Oh, I
didn't-
gotcha. Okay, I'll take a look. See, I'm sorry. Yeah,
Okay,
it was
no,
a
no
multi.
worries.
Okay,
Okay. All right.
thank
Well,
you.
thank you very much.
You're doing a great job.
I'm trying.
I know.
All right. Well, hope
Not
your
for
feet
the
are,
weary.
your knees are better. Hope your knees
Yeah,
get
me
better.
too.
I have to say, I have issues too.
I know. No fun. No
Having
fun.
surgery probably in a couple weeks. So
Yeah, and then you're not prepared for the swelling and the ankle swelling, things like that, or bruising. It's just like, oh yeah.
what was mine's a meniscus.
Well, I already had two, so I had two surgeries to both meniscus, but they were
That's what I
going in
have.
and doing some cleanup work.
Yeah, that's what I'm probably, I went to the doctor today and I'm doing
Then you have to do
probably
physical therapy.
I've been doing it for
Yeah.
3 months already, and we
Yeah,
thought maybe I could get away without
no,
surgery, but
You can't. It doesn't
I
repair
know.
itself. That's a waste. You have to do the physical therapy afterwards. But
Yeah.
that was a pretty clean one. Yeah. This is just anyway, like some cleaning up arthritis and things and getting it. Yeah. So
Well,
it's
I
good.
hope you feel better.
Oh, thank you.
Ice.
I know.
All
I
right.
have a glorious day. Thank you.
Thank you. Thank
Okay,
you. You
bye now.
too.